I hope you guys have some questions for me, that like revision questions that you'd like me to go over. All right. Anyway, let me start by so what we have covered all the topics for the course so far, and so that's from week 1 to week 11. So this is week 12 is just a revision week. It just I will go through some questions you may have. Right now, to prepare for the exam, as you know, the exam is on the 9th of June, next month. All right, so to prepare for that exam, what I advise you to do is to go through the past exam papers. So if you go down the website, you see there's a section called final exams, and it contains the last 6 years exams papers and the solutions. So that should help you to prepare for the exam, which is in June, right? And on top of that, you can also go through the in-class test. I mean, there was no in-class test this year, but there were 3 in-class tests in the previous years, and you can look at them and their solutions, right? And on top of that, you can also go through you see the quizzes, like this section here gives the 10 quizzes and the solutions for 2019, 2020, right? And this section here gives the 10 quizzes and the solutions for 2018, 2019, right? You guys okay? Excuse me. Right, and also you can also look at the 10 quizzes and the solutions that we did for this semester. So there's plenty of resources in this course website, right? There are plenty of resources in this course website, and that should be more than enough for you to prepare for the exam in coming up in June. And on top of that, I'm going to be in Manchester throughout the period leading to the exam. And for any questions you guys have, you can contact me 24/7 by email, Skype, Zoom, or phone. You know my phone number, so you can. I'm also happy to meet you. If you're going to be in Manchester just before the exam or during the exam, I'm happy to meet you and go through problems with you, right? Okay, guys. So that's all I have to say about the exam. I mean, do you guys have any questions that you'd like to ask me now about the exam? Or also, do you guys have questions like revision questions? You like me to do right now? Is there anything that we? Yeah. By the way, the ARC course. I just sent an email to all of you this morning, giving a reminder of the ARC coursework. The ARC coursework is due, as you know, on Thursday. The coming Thursday, 10 o'clock UK time. You should submit your work through Blackboard. You can type the report, the 5-page report, in Word or LaTeX. In either case, please convert to PDF before submitting it. If you have problems converting it to PDF, you can just submit the Word document, right? And if you're using LaTeX, then please convert to PDF before submitting it. All right. Okay, guys. Any other questions about our coursework? Yes, you can use Word. Yeah, you can use Word to type the 5-page report too. And again, I mean, if you're using Word, you should be able to convert to PDF easily. But if you cannot, for some reason, if you cannot convert to PDF, you can submit the Word document directly to Blackboard. Okay. Charles, yeah, there will not be any question. I mean, for the exam, yes, for the exam, there will be no questions on two sample confidence intervals or two sample test of hypothesis. Yeah, thank you, Charles, for raising that. Yeah, I mean, the exam will contain no questions on the two sample uh, confidence intervals or two sample test of hypothesis. Other questions, guys? Please keep coming, guys. There won't be, yeah, that's right, yeah, there will not be, yeah, there will not be any questions on the two topics, that is the two sample confidence intervals and two sample test of hypothesis, right? Okay, all right, what I'm looking for this session is conversion problems. I mean, do you guys have any questions you'd like me to do? Oh, sorry. Somebody sending me an email. Let me close the email so we can. All right. Is the test handwritten or online? The test will be, I mean, it's online, yeah, but I think you will need to write your answers from wherever you are, and then upload the answers to Blackboard. I think you will be given additional time to upload the answers to Blackboard. So the exam is 2 hours long, just like the previous year's exams. But maybe you'll be given half an hour extra. You'll be given half an hour additional time to upload your answers to Blackboard. I mean, that's what happened last semester in semester 1. Alexandra, yeah, the test will include yeah, you're right, Alexandra. Yeah, yes, you're right. And the art coursework and the exam, I will mark all of them by myself. I do not use teaching assistants, as you may know. I mark all the. It's a hell of a lot of work, but I will do all the marking by myself. I mean, because as you know, there are more than 500 students taking this course, so it will need quite a bit of work. I mean, I don't mind doing that. So it's the art coursework. I hope to get. I hope to send you your marks by next week sometimes. So you should receive an email from me sometimes next week, telling you what mark you got for the art coursework and the feedback. The number of questions, Bailey, is the same as in the previous year's exam. So if you look at like last year's exam, let me show you. Okay, let me go back to the. Yes, Mikhail, you're right, Mikhail, just a minute. Give me, all right, this is last year's exam paper. Let me show you. This is last year's exam paper. So we have two sections, section A and section B. Section A has, as you can see, section A has 4 questions. Right? It has 4 questions, and you will need to answer all of them, all 4 of them. Okay, and section B has 3 questions, and you will need to answer any 2 of them, right? So in total, you'll have to answer 6 questions, right? Okay, so once again, section A has 4 questions, so you need to answer all 4 of them, right? And section B has 1, 2, 3 questions, and you will need to answer any 2 of them, right? Okay. All right, guys. Does it make sense? Yes, Neil, you're right. I mean, there will not be any questions on 2 sample confidence intervals or 2 sample test of hypothesis, but there will be questions on 1 sample test. Yeah, there will be questions on 1 sample test or 1 sample confidence intervals. Yeah, the exam is worth 80%. You're right, Stefan. Yeah, the exam is worth 80%. So it's 80% exam, 10% R coursework, and 10% the 10 quizzes. So its total is 100. So now you got the marks for the 10 quizzes. So you should know now you should focus on the R coursework, which is worth 10%. And as I said, I will send you the marks for your R coursework personally sometimes next week, along with the feedback and the solutions to the R coursework, right? Okay. Right. And other questions, guys? Keep asking me some questions, guys. Hello. All right. So okay. So what I'm going to do, let's see, what I'm is to do some. Do you guys have some revision questions you want me to do now? If you don't, I will try to do some questions myself. Okay. Well, it's a written exam. I don't know what you mean by online exam. It's a written exam. Yeah, it is a written exam, Bailey. So it's basically you write. You'll be given a list of questions. And you will need to write your answers on papers that you have at home or wherever, and then upload the scanned version of your answers to Blackboard. Right? Is that clear, Bailey? Okay, so it's I don't know what type of exams you guys had last semester, but the exams that I normally give are like yes, you can use iPad, Vincent. Yeah. Okay. So all right. Anyway, just keep writing your questions and I will answer them. As this is the exam from 2018-2019. All right, and I'm going to do one of the questions right now. I'm sure you know where to find these exams. So one of the questions in this paper was, this is the last question. I don't know if you can read this. Maybe it's much better than the visualizer I had last week. So this is question B7. This is B7 from exam paper. The exam timetable is wrong. I really don't know what they mean by online tests. I mean, this is all done by the people in the teaching and learning office. I have no idea what they call it. I have no idea what they call an online test. It's not a multiple online test. I mean, it's basically. I will clarify with them later today. I'll try to email them. I think what they meant by online test is just, write down, as I said before, I mean, I set up all I wrote the exam paper myself. So the exam that you will be sitting, it means that you have to write down the answers to the 6 questions that you need to do, which is 4 questions from section A and 2 questions from section B, and then upload the answers for the 6 questions that you have done to Blackboard, right? Okay, I mean that's all I know, but I don't know what. I have no idea what the teaching and learning office what kind of information they gave you, I have no idea. Anyway, I will check with them later today and see what's happening. Okay. Right. So this is I just want to do this question, right? This is question B7. Question B7 in exam paper 2018-2019, right? So basically the questions say, can you see this, guys, or no? Portrait. Okay. Okay, thank you. If you cannot see it, let me know. Yes, I have solutions for all the past exam papers. I mean, I have solutions for the all. I mean, I just showed you all where the solutions are, guys. And you should go back to the share screen. Sorry, didn't I show you just a minute ago? You should go back. You should go to the course website. You will see where the solutions are. Okay. All right. So the question says the following: you have 4 random variables x1, x2, up x3, and x4. Their IID uniform random variables on the interval 0 to theta, right? Right, and it also says that the actual variable that we observe is called y, which is defined as the minimum of x1, x2, x3, x4. Okay. Right. Now, the first part of the question is asking you to determine the cumulative distribution function of the random variable y. Right. So we want to find the CDF of y. Okay. So the CDF of y is going to be okay. This is the notation I will use. I mean, I think you are familiar with this notation. This is the probability that capital Y is less than or equal to y. And this you can write as 1 minus the probability that capital Y is greater than y. Okay. And this is 1 minus the probability that the minimum of x1 to x4 is greater than y. Okay. And this is, okay, if the minimum is greater than y, then you can say that x1 is greater than y, x2 is greater than y, x3 is greater than y, and x4 is greater than y. Okay. All right. Feel free to ask me if you're not clear about anything. Okay. Now, because of independence, we are assuming that the variables are independent. You can write this as yeah. All right. Now, each of these probabilities is the same, right? Each of these is the same because they are independently distributed. So what you have is the probability that x1 greater than y to the power 4, right? Because each of these is identically distributed, each of these random variables, right? So this you can write as 1 minus the probability that x1 is less than or equal to y. Yeah. And this is 1 minus the probability. Now, what you have here is the cumulative distribution function of the uniform of this random variable, right? Okay, which is, I'm sure you know from probability 1, you took last semester, that the CDF of a uniform variable is Okay, with this, yeah. You guys okay? Are you following me okay so far? If you're not, please let me know. So this is 1 minus y divided by theta to the power 4. So this is the answer to part one of question B7, 2018-2019. Right, part two is to write down the likelihood function of theta based on a single observation of y. All right, now remember the likelihood function. So this is part two of question B7. Remember, the likelihood function needs the density function, not the PDF. Now, what we showed in part one is that this is equal to 1 minus y divided by theta power 4, right? Now, what this implies that the density function, or the PDF, which is the derivative of this, is going to be this, right? All right, guys. So the likelihood function of theta, because you only have a single data point, you only have one data point, so the likelihood is the same as the density function, because there's nothing to take the product over. Remember, the likelihood is usually the product of the density function over the n observations, but in this case, n is 1, because you only have a single data point, right? So the likelihood is equal to this, right? Right, so that's the answer to part two of question B7. Right, the next part is to derive the maximum likelihood estimator of theta. Right, now to derive the maximum likelihood estimator, well, I'm sure you know, I mean, I've done enough examples on this, so you should know how to do it. So the first step is to take the log of the likelihood, which is going to be the log of this. So it's going to be, okay, let me try to simplify this guy here first. This you can write as like this, yeah, okay, so the log of this is going to be log of 4 plus 3 times log of theta minus y minus 4 times log of theta, yeah. All right, so this is the log likelihood function, and the next step, I'm sure you know, is to take the derivative with respect to theta, which is going to be 3 divided by theta minus y minus 4 divided by theta, and set this to 0 and solve for, correct me if I made any mistakes. All right, solve for theta. So this implies that 3 over theta minus y is equal to 4 theta, all right, which implies that 3 theta is equal to 4 theta minus 4y. All right, so this implies that theta is equal to 4y. All right, so I use the notation hat. I'm sure you're familiar with this. So hat means that it's an estimator of theta equal to 4 times y. Now, to show that this is a maximum likelihood estimator, we need to take the second order derivative of the log likelihood, which is the first order derivative of of this one here. So it's going to be minus this minus plus 4 over theta squared. Now we need to show that this guy is negative. Now how do we do that? Any ideas? How can we show that this guy is negative? All right, okay. Now basically we need to show that it's negative at theta hat. So I'm going to put theta equal to theta hat into this equation, right? All right, so this will become 3 over 4y minus y squared, right? Plus 4 divided by 4y squared. All right. Now this is going to be minus 3. 4y minus y is 3y. Right? 3y squared is 9y squared. And now 4 divided by 16y squared. Right? Right? Okay, so this is going to be minus 1 over 3y squared plus 1 over 4y squared, right? And this is clearly less than 0. Okay, you guys with me? So what we have shown is that we have shown that theta hat equal to 4 times y is an MLE of theta. Right? Are you guys okay with this or no? Okay, talk to me. Are you okay with this? Are you okay with this solution or no? Thank you. All right, so let's go to the next part of question B7. Find the bias of the estimator in part 3, and is the estimator unbiased? Right. Right, now I'm sure you guys remember what a bias is, right? So this is part 4 of question B7. So you have this estimator theta hat equal to 4 times y, right? Now we need to find the bias of it, right? So remember the bias of the estimator is the expectation of the estimator minus the parameter that you're trying to estimate, right? Okay, which is going to be the expectation of 4 times y minus the parameter that you're trying to estimate. So this is 4 times the expectation of y minus theta. Right, now remember earlier that we showed that this guy here is the density function of y. This is the density function of y. So to find the expectation of y, all right, what you need to do is you need to integrate between 0 to theta. This is theta, right? From 0 to theta of y times like this, all right? All right, now any ideas? I know this is kind of, maybe this is a trick, maybe a tricky integration for you guys, but let me, so this is going to be 16 theta right? Now, one way to do this integration is to expand this term here and then integrate term by term, right? Okay. right? But another way to do this, an easier way to do this integration is to use something called the beta function. I'm not sure. Have you guys heard about something called the beta function before? Had you heard about this before? No? Yes? You haven't heard about, or some of you haven't, so I don't know. Anyway, I mean, one way, I mean, there are many ways you can do this integration. One way is to expand this, the second term, right, and then do term by term integration. And anyway, I think I don't want to spend time on integration in a revision class. So I will just leave this for you to do, right? Okay. Okay, there's one question from why we integrate from 0 to theta. That's because that's a good question, because you should go back to the beginning of the question. It says that these 4 random variables each are from 0 to theta. Right, so that's exactly why we are integrating from 0 to theta, because since these 4 variables are defined between 0 and theta, y, which is the minimum of these 4 variables, is also defined from 0 to theta. All right, so hence, when I come here to finding the bias, the limits of integration should be from 0 to theta. All right. Now I will leave this integration for you to do, because I don't want to waste my time. I mean, I don't want to waste your time also doing integration during a revision class. Okay. All right. So that's one question I wanted to work on. Any other question you like me to do the revision on? No, you guys have some questions you want me to work on. Hmm? Come on, guys, talk to me. Do you have some questions like this? This is past year's exam. This is the exam paper from 1819, no, 2018-19. If you have questions, please do let me know. Trying to find some questions for you. Not this one. Maybe this one is different. I think this is about this. No, not the beta. You don't need to know the beta function for the exam, Alexandra. No, not for the beta. Not for the. Yeah, let's do this question. You don't need to know the beta function for the exam. All right, so this is from, I don't know which year it is, but I think it's last year. I think this one is from last year. This is question A4. Question A4. I think this is last year's exam, 2019, 2020 exam. Right? All right, so I will the first 2 parts are bookwork, right? A and B, they are bookwork, right? So I will just do the part C. I will do only part C, which is the following. Suppose you have a random sample from this CDF, where x is greater than theta, and show that the CDF of the minimum is given by this. Okay, so you have, so this part C, part 1. So you have Z equal to the minimum of x1 to xn, right? And we want to find the CDF of Z. We want to find the CDF of Z, which is gonna be Right. I think I already done this. I already showed you how to do something similar. Mm. Okay. Right. And this is going to be 1 minus the probability that the minimum yeah. Now, if the minimum is greater than, then this is, you can write it as like this, right? And since these are independent random variables, you can write this as the probability that like this, yeah. And next, since these probabilities are the same, you can write this as each of these probabilities is the same, so you can write this as the probability that x1 greater than z power n, right? Now this guy here is this guy here is the you can write it as 1 minus the probability that x1 is less than or equal to z. Yeah. Now this is the CDF of x, which is given to us as this guy here, right? So it's 1 minus. So what you have is 1 minus 1 minus minus is plus exponential of theta minus z power n, right? Now these two guys cancel out. So this will be 1 minus e of n theta minus nz, right? Okay, guys. So that proves the first part of question part C, right? Now second part is to derive a 100 times 1 minus alpha confidence interval for theta using the result in part C. Right now so let me show you how to do that. So to derive 100 times 1 minus alpha confidence interval, we just said, I think I showed you how to do this before. You need to find the two limits, right? So to find the lower limit, which I'm going to denote by L, right? I set the CDF of at L to be alpha by 2. To find the upper limit, which I'm going to denote by U, you find the CDF, you set the CDF to be 1 minus alpha by 2. So from this equation, you can see that 1 minus E n theta minus NL is equal to alpha by 2, right? And this implies that yeah, and this implies that n theta minus NL is equal to log of 1 minus alpha by 2, right? And this implies that theta minus L is equal to 1 over n times log of 1 minus alpha by 2. All right, so L is the lower limit of the confidence interval is theta minus 1 over n times this. Right, so this is the lower limit of the confidence interval. Right, to find the upper limit of the confidence interval, we will use this equation, right? So this is 1 minus E yeah. So this implies that yeah. Right. Now taking the logs both sides, you get n theta minus n u equal to log of this, and theta minus u is equal to 1 over n times this, yeah. And finally, your u, the upper limit of the confidence interval, is theta minus, right, so this is the upper limit. All right, so you got the lower limit and you got the upper limit. So hence the conclusion is that hence 100 times 1 minus alpha percent CI is, right, is just the interval from the lower limit, which is to the upper limit, which is right. Okay, guys. So this is clear with you guys or not? Hello, guys. Talk to me. So this is it. This, I mean, you will have a question on confidence interval, one sample confidence interval. So this is how you should try to address it. Okay. All right, guys. So, right. Any other questions you'd like me to do, guys? Let me know, please. So this is from last year's exam paper. It was last year's exam paper, question A4. Can we go over under what circumstances we can set a normal distribution equal to chi-squared and the t distribution? Oh, okay, that's a good question, I think. All right, yeah. Thank you, Robert, for asking that question. So the question is this, that is, if there are certain properties that I talked about which relate the normal distribution to the chi-square distribution. Now, one such property I talked about is this. If you have right? You remember this property, guys. This is a property that you need to know. Right? This is wait. In this question here. Oh yeah. I haven't finished this. Yeah, sorry guys, sorry. Thank you, Mikhail. Let me get back to this question here. I think it's not. Let me get back to this question. Let me get back to this question here. I think I haven't finished this question, guys. I'm going stupid today, I don't know. So what I have said here, guys, is the probability that that z is the variable, right? Between u and l, between l and u, right, is equal to 1 minus alpha, right? L is the lower limit, U is the upper limit. So this is the same as saying that the probability that L, which was theta minus U, which was okay. Thank you, Mikhail, for pointing this out. I think it was my mistake. All right, so this is what you get. Now you can rewrite this as a statement on theta. Now this you can write it as the probability that theta is less than or equal to z plus and theta greater than or equal to z plus 1 over n times log of alpha by 2. Yeah, and this is the same as saying that the probability that theta lying between z plus 1 over n and z plus 1 over n times log of this is 1 minus alpha, right? Okay, hence, so the final conclusion is that hence the 100 times 1 minus alpha confidence interval for theta is from this to this. So the lower limit will be this, and the upper limit will be this. All right. Thanks again, Nikhil, for pointing this out. Yeah. So this is the correct solution to the confidence interval for question A4 from last year's exam paper. Right. All right. Okay. Now let me get back to the question from Robert, which was about the relationship between the normal and the chi-square. Now, one result I mentioned is this, that if you have a random sample from this, then this has the chi-square distribution, right? And another result I mentioned is this, if you have right, then this result is also true. You see the difference between these two results. Here, the deviations is with respect to the sample mean, and here the deviation is with respect to the population mean. That's why here you have the chi-squared with n minus 1 degree of freedom, and here you have chi-squared with n degree of freedom. Right? And another result I mentioned is the following. Right, with this. Right, is this, that if you have a random sample from this, then this guy here has the t distribution with n minus 1 degree of freedom. So these are three very important results. This one, and this one. All right. They may crop up anywhere in any. I mean, in the first one, it doesn't need to be 0. I mean, mu can be anything. It doesn't need to be 0. Yeah, you're right. Yeah. Yeah. So these three properties are really important, right? And they can crop up anywhere. Right, and by the way, this property, the first property, can also be written like this. The first property can also be written as n minus 1 times s squared S squared, remember, it's the sample variance divided by sigma squared as the chi-squared with n minus 1 degree of freedom. So these two, this and this are equivalent formulas, right? These two, right? All right. So these are three important properties that you may need to know for the exam, because they can crop up anywhere, and you should know which one to use where and use it correctly. All right. Okay. Yeah. All right, guys. So I think the time is up now. So, I mean, as I said before, you've got lots of resources to prepare for the exam, and on top of the resources, I'm here for you 24/7. Right. So, any questions you guys have, please feel free to contact me by email, Skype, Zoom, or phone. Right. I'm also happy to see you in person if you are in Manchester. Right. S here is the sample standard deviation, Vincent. S is the sample standard deviation. So, yeah. Okay. All right, guys. So have a great morning. By the way, there's a tutorial right now. In 10 minutes time, there will be a tutorial. So if you want to attend that, please hang on. Right? Okay. Anyway, have a great day, or have a great morning or afternoon wherever you are, and I will see you shortly. Right? Okay. இப்படி இல்லை எனக்கு இப்படி 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 மாத்து இப்படி இல்லை நிக்குது இப்படி மாத்து
திருப்பிதான் வராங்க அதை ரொட்டேட் பண்ணல ஓகே
இல்ல அது அப்படி
திரும்ப திரும்ப
இப்படி இல்லை
இல்ல வேற வராதா
இப்படி வருது
திரும்ப திரும்ப ரொட்டேட் பண்ணிக்கணும் மெட்டு மேலே என்ன இருக்கும் இல்லையே லேண்ட்ஸ்கேப்
லேண்ட்ஸ்கேப் வந்து இப்படி எழுதுவோம்
எப்படி எழுத போறீங்க வடிவ சொல்லுங்க
இல்ல இப்படி எல்லாம் இருக்கு இப்படி
வைட்
பண்ணுவானு குழப்பாங்க
இது இன்னும் வைட் பண்ணாது ஏன் வைட் பண்ண லேண்ட்ஸ்கேப் இது லேண்ட்ஸ்கேப் என்றால் புரியல வேற இல்ல இப்படி வந்த லேண்ட்ஸ்கேப் இப்படி வந்த லேண்ட்ஸ்கேப் we want it to be like this
இது ஜெனரல் ஒரு மாத்தணும்
இது திருப்பி விட வேண்டாம்
ஜெனரல் வருது
வீடியோ வேணும் வீடியோ அட்வான்ஸ் போங்க Video capturing meter, video rendering meter. என்ன பிரச்சனை இதுல புரியுது?
நிறைய மாதிரி கிடக்குறாங்க.
அவங்க சொல்றாங்களா? நிறைய மாதிரி கிடக்குன்னு சொன்னாங்களா?
இல்ல இல்ல
இவ்வளவு தானே பேர் அவங்களே சரியா தானே வேணும் ஸ்கிரீன்ல ஃபுல் ஸ்கிரீன்ல போட்டு பார்க்கல. ஃபுல் ஸ்கிரீன்ல பெருசா தானே வேணும்.
சரியா நீ போட்டு வா. அப்புறம் தண்ணி போட்டு காட்டு. ஓகே